Welcome to all. Today we will look into the first angle projection and third angle projections in engineering graphics. These are the different types of planes. We have already discussed about various planes, principal planes HP and VP, horizontal plane and vertical plane. Here VP is the plane which is vertical. VP is a reference plane which is vertical, and HP is a horizontal reference plane, and that HP is always perpendicular to VP. And in the second case, there are three types of auxiliary planes. First one, auxiliary vertical plane, AVP. Second one, auxiliary inclined plane, AIP. Then profile plane, PP. Profile plane, PP. And the auxiliary vertical plane is a vertical plane. Vertical means that's perpendicular to HP. Auxiliary vertical plane is a vertical plane which is inclined 5 degree. Inclined 5 degree with VP. Inclined 5 degree with VP. Here this inclination is equal to 5 degree. And auxiliary inclined plane is a plane which is perpendicular to VP but inclined to HP. Inclined to HP. And that inclination is represented by theta, angle theta. Inclined theta degree with HP. Finally, profile plane. Profile plane is a plane which is perpendicular to both HP and VP. A plane which is perpendicular to both HP and VP is known as profile plane. These are the different types of planes. While we considering the concept of orthographic projections. Ortho means perpendicular. Then orthographic projection is a projection of different objects in mutually perpendicular planes. HP, VP and PP. These are mutually perpendicular planes. And a view in which visual rays are perpendicular to HP. A view in which visual rays are perpendicular to HP is known as top view. A view in which visual rays are perpendicular to VP is known as front view. And a view in which visual rays are perpendicular to PP is known as side view. This is the three types of views. And coming into the next portion, here we can discuss the pattern of planes and views in first angle projection. That means a first angle projection means that object, this is the object or this is the point, and that point resting in first quadrant. That point is resting in first quadrant. And we can unfold these mutually perpendicular planes and make that three-dimensional view into a two-dimensional view or a plane view. Here, if we rotate that profile plane like this and this horizontal plane like this, we can rotate that horizontal plane in clockwise direction or in the downward direction, and this we can rotate that profile plane in anti-clockwise direction. Then we will get a plane view of a first quadrant, plane view of first quadrant like this. Here the front view is in this particular plane VP, and this is the left side view of the object. That is in PP. And Here the HP is below the VP, below the vertical plane, and that view, top view, is always below the vertical plane, or that is top view must be in horizontal plane. Here we can treat this axis as x-axis, and this axis as y-axis, and this axis as z-axis. Here x, y, and z. Then we can represent that xy as this horizontal straight line xy, and this vertical line as zy dash. This y dash means apparent y axis. Here this line is this one, and this point is origin 0 0 0. This point is origin, and this one is apparent y axis. Then above xy line, in first angle projection or projection in first quadrant, a front view and left side view or right side view, is always above xy line, and the top view is always below xy line, and this left side view is at the RHS of zy dash, and this type of pattern of planes is there in first angle projection. Here to make those planes also visible from the arrow direction, first condition, HP is rotated 90° downward, and PP 90° in right side direction. PP 90° in the right side direction. Okay, this is the procedure, and that view pattern is like this. XY, this is the XY axis, and this is ZY dash axis, and HP is this plane, and VP is this plane, and PP is this plane. So front view is always at this space or above XY line, and top view is always at below XY line, and this is the space for side view. This is the representation of first angle projection, or simply we can represent first angle projection as XY line, and above XY line VP, and below XY line HP, while we didn't considering this the profile plane. This is the simplest representation of first angle projection, or first quadrant, XY line, above XY line VP, below XY line HP. Actually this is the origin 0 0 0, and right side of the ZY dash axis is always represented by profile plane. And methods of drawing orthographic projections: first angle method and a third angle projection method. Here in the first angle projection, front view is always above XY line, and top view is always below XY line. Actually this is the front view and top view of the frustum having axis perpendicular to HP, and we can represent this as the representation of first angle projection. And in the third angle projection, actually that object is lying in third quadrant. We can discuss this third angle projection in detail in coming classes. And this is the representation of first angle projection. Here this object is lying in first quadrant. That means if we consider this is this quadrant as first quadrant, and this quadrant as second quadrant, and this quadrant is third quadrant, and this one fourth quadrant. This is first quadrant, and this is second quadrant, and this is the detailed view of the first quadrant. Here this object is lying in first quadrant, and this a view in which visual rays are perpendicular to VP. Perpendicular to VP is known as front view, and that front view is always in VP. And a view in which visual rays are perpendicular to HP is known as top view, and the top view is always in HP. And in a view in which visual rays are perpendicular to PP is known as side view, and that side view is always in profile plane. Side view is always in profile plane. And we can have this type of view in first angle projection. Here this line is XY line, and this line is ZY dash, and this Y dash is the apparent Y axis. And above XY line there is a front view, and below XY line there is top view, and the RHS of ZY dash is representing the profile plane, and that view in profile plane is representing as side view. This is the actual representation of first angle projection. And when we consider a frustum lying in first quadrant, frustum means actually a part of cone. Here this frustum is lying in first quadrant in such a way that its axis is perpendicular to PP. Then that front view is like this. Front view is like a trapezium, and this side view is like two concentric circles. Then if we are representing this front view and this side view, in a plane, then we can represent that as the front view is like this. Front view is like a trapezium, and this side view is the two concentric circles having diameters equal to the two vertical sides of the trapezium. Actually this is the representation of the first angle projection by using in ordinary drawing sheets. This is the representation of first angle projection. Here actually this front view, this trapezium is a front view of the frustum lying in first quadrant, and this two concentric circles is the side view of the frustum lying in first quadrant. And actually this is the representation of the first angle projection. Okay. For front view, that visual rays must be perpendicular to VP. For top view, visual rays perpendicular to HP. And for side view, that visual rays perpendicular to PP. Okay, then in the third angle projection, actually that object lying in third quadrant. Here, this is the third quadrant. Here, we have a frustum lying in third quadrant. Then in front view, here again that visual rays must be perpendicular to VP. And also an additional condition is there. That is nothing but that reference planes. These reference planes must be transparent in third angle projection. Then only we will get that views, front view, top view, and side view. Here in the side view we can have these two concentric circles, and in front view we have this trapezium. We have this trapezium. When this reference planes is a transparent plane, then we can represent that third angle projection, or in third angle projection we can represent that object, the different views of this particular object as he like this. Left side views at this portion, and front views at this portion, and top view is above front view. Top view is always above front view. Or we can represent that third quadrant in the simplest way like this: xy line above xy line HP, below xy line VP, below xy line VP. And we can represent that third angle projection as like this. This is the center line, chain line, and two concentric circles like this, and the trapezium like this. And this is the representation of the third angle projection. Here two concentric circles must be at the LHS of the trapezium, LHS of the trapezium, LHS of the trapezium. That means that object is lying in third quadrant, and all the reference planes are transparent. All the reference planes are transparent. That is the most important condition. Most important condition in the third angle projection. Third angle projection. Thank you. Thank you all.